Google Notebook LM, and an old PDF I found in the archive.org. So let's see what happened. It's sure to be informative. Let's go.
Okay, let's unpack this. We're diving into a really unique source today. A book from 1984, published in the Soviet Union, called Cybernetics Today.
Right.
And this isn't just any book, is it? It's a collection essays and discussions from really prominent Soviet scientists.
Yeah, top tier people, academicians, corresponding members of their Academy of Sciences. They're talking cybernetics, automation, AI, past, present, and future, as they saw it then.
And that date, 1984, it just sets such a fascinating scene.
It really does. I mean, you're right on the edge of the personal computer revolution starting to spread widely in the West, but it's still rooted in a very different tech world.
And a different society, definitely.
Absolutely. So getting their perspective from that moment, from those experts, it's a very distinct lens, you know.
Yeah, absolutely. So our mission, I guess, for this deep dive is to pull out the key ideas, maybe the surprising predictions, the debates they were having back then, almost 40 years ago now, and see what insights this specific viewpoint offers us today about, well, man, machine, knowledge, all of that.
What did they focus on? What maybe slipped by? And what questions were they asking that, well, still feel incredibly relevant?
Exactly. It's like holding up a mirror to our own talks about AI and tech, but seeing it reflected through, well, brilliant minds from a different time and place.
Couldn't have put it better.
So let's start right at the beginning. The core concept, cybernetics. How did they define it? What did it mean to them in 84?
Well, the book basically presents it as the science of control and information handling. That's the fundamental idea.
Control and information handling. Okay.
Yeah, it covers the mathematical side, the technical side, but also the theory behind how data gets transmitted, how it gets processed.
So it's kind of the study of how systems manage themselves and deal with information.
That's a good way to put it. Whether those systems are like machines or biological organisms or even, social groups.
So really broad then, much broader than just building computers.
Oh, yeah, much broader. It's about the underlying principles. And the book points out that by the mid 80s, cybernetics had already sort of faced some corrections.
Corrections.
Yeah, maybe some of the very early utopian hopes hadn't quite panned out, real world problems cropped up.
Okay.
But even with those adjustments, the experts writing in this book, they still saw huge potential, really dazzling possibilities ahead, as they put it.
And the fact that the contributors came from math, engineering, other fields, it really shows this was seen as fundamentally cross-disciplinary, doesn't it?
It does. Their expertise is all over the map, from very practical control systems to really abstract theory. And you see that breadth in the topics they tackle.
Which naturally brings us to one of the biggest topics in the book, artificial intelligence.
We know.
It seems pretty clear reading this that even among these top scientists, there wasn't like one single view on what AI was, or even if artificial intelligence was the best term to use.
Yeah, that disagreement, that's one of the first things that jumps out. You have one perspective in the book that defines intelligence. Any intelligence, natural or artificial, purely by its function.
How so?
Basically, the ability to make a good decision in a tough situation by using your available resources efficiently.
Okay, so it's about the outcome, optimal results under constraints.
Exactly. And from that point of view, there's no essential difference between a human doing that and a machine doing that. Functionally, it's the same kind of intelligence.
That feels very practical, very engineering focused, maybe, for 1984, focusing just on the result.
It does feel that way. But then you had others who were uncomfortable with the term artificial intelligence itself.
Why was that?
They felt it brought up irrelevant associations, was the phrase used. Science fiction stuff. Thinking machines.
Ah, okay. The classic can machines really think debate, even back then.
Right. They thought it was maybe misleading or jumping the gun a bit.
Got it.
And the researchers they highlight, they weren't just trying to build systems to mimic one specific task, like only playing chess or only composing music.
No. What was the deeper goal?
It was more about simulating the overall psychological mechanisms that organize those complex processes.
Okay, so not just the chess move itself, but the strategy, the learning, the way a mind approaches the game, simulating the underlying thinking.
That's the idea they were pushing, which leads straight into this huge philosophical debate in the book. Machine creativeness.
Can machines be creative?
Exactly. Is reasoning, is creativity something unique to the human mind?
Mm.
Or can intelligence, including creativity, exist in other forms, specifically forms made by humans?
And this sounds like that split you mentioned, the engineering versus the humanistic oriented view.
Pretty much. The book even notes that these views sometimes had, well, strong emotional roots, and occasionally prejudices could creep in, maybe some tech folks looking down on the humanities a bit. And the humanistic side often raised a key objection. Machines can't really be creative because they only do what humans program them to do.
Which sounds reasonable on the surface, right? How can something new come from just following orders?
Right. But the counter argument from the cybernetics side is really important here. They pointed to machines being developed that could learn and even self learn
Self learn? How?
by interacting with the world around them. And this is key, modifying their own programs based on what they experience.
Ah, okay. So the creativity doesn't just come from the initial programmer.
No, it could emerge from the patterns in a kaleidoscope, or how an artist might see something inspiring in random ink blots. The point was that chance isn't the opposite of creativity. It's actually a part of it, a constituent element.
So if you build a system that can generate possibilities randomly and then somehow select the good ones.
You're simulating a key part of the creative process.
Yeah, exactly. They actually broke creativity down into two stages.
Which are?
The preparatory stage, just generating lots of variants, lots of possibilities, and then the selective stage, picking the best ones.
Okay.
And they argued machines were definitely helpful in that first stage, preparation, super fast computation, generating way more options than a human ever could.
Right, like thousands of musical snippets or design variations in seconds.
Exactly. Now, the selective stage, choosing the best one, that was harder for machines. They admitted that.
Makes sense. Taste, judgment, that
Yeah.
feels more human.
True. But even there, machines could help. They could filter out options that didn't meet basic formal rules.
How so?
Like in music, a machine could discard compositions that break fundamental rules of harmony or counterpoint. It could narrow the field based on objective criteria. So it handles the rule based filtering, even if the final artistic choice is still human.
That was the idea.
Mm.
It shows how these systems could augment creativity, even the tricky parts. But this discussion about what machines could do naturally led them to think about limits, potential thresholds for AI.
Limits. I thought they saw dazzling possibilities.
They did, but they also saw significant hurdles. The first one was just the sheer complexity of the human brain itself as a biological system.
The hardware problem.
Pretty much.
Mm.
They threw out numbers like 10 billion neurons, 100 trillion connections. They saw the brain back then as just vastly superior at collecting information than any artificial system or even any other natural system they knew of.
So biology was the first big wall.
Right. And they weren't just thinking about standard computers to overcome this. The book actually describes this concept of an optical brain.
Optical brain using light.
Yeah. As a theoretical way to get like unbelievably fast processing speeds. They were
Yeah.
talking 10 to the 20th operations per second.
10 to the 20 per
Uh-huh.
second. That's still mind-bogglingly fast compared to even today's supercomputers.
It tells you the scale of their thinking, right? The idea involved lasers, holograms, layered structures mimicking neurons. That incredibly complex connection structure, they saw that as even more challenging.
So designing the relationship.
Big threshold they discussed, the social nature of intelligence.
Social nature, what do they mean?
They argued that human intelligence isn't just a biological thing. It's deeply shaped by history, by society, by culture.
So thinking isn't just what happens inside one person's head. It's collective. Involves language, culture.
That's the core idea. They talked about will, motivations, the collectivistic nature of knowing things. Science itself was their prime example. It's a social institution, right?
Yeah, it builds on itself over time across people.
Exactly. And this raised a really deep question in the book. Do we even need to build that social part, the history, the motivations, into a computer? Can you?
Mm.
They connected this to big ideas about historical laws, social responsibility. If intelligence is fundamentally social, can you replicate it outside of that social context?
That's a heavy philosophical question right there.
And there was another argument against AI based on this idea of disjunctive versus non-disjunctive. Whereas living things and their minds were seen as non-disjunctive, they emerge holistically from a single starting point, like a fertilized egg, through continuous unbroken development.
Ah, so it's about how they fundamentally come into being. One is built, the other grows.
Precisely. And this view argued that true AI is theoretically impossible because machines are fundamentally built, assembled things derived from human design, whereas natural minds emerge through this continuous, holistic biological process.
So it's an argument against AI based purely on its origin story, in a way.
You could say that. It's a deep philosophical objection. So the takeaway is even within this group of elite Soviet scientists, you had fundamental disagreements, not just on how AI would work, but whether it was even possible in principle.
Wow. It shows there was real, probably quite intense debate happening.
Absolutely. But okay, beyond the theory and the limits, the book also dives into practical stuff. Applications of cybernetics that were already happening or looked like they were just around the corner. Some are quite surprising.
Okay, let's shift to that. Where was cybernetics actually being used, or where did they see it going?
Well, a huge area was control systems. They talked about moving beyond controlling simple things, cars, planes, factory machines,
Right, standard automation.
to managing much more complex, often ill defined things, like whole cities or large regions.
Controlling a city? How would that even work? That sounds incredibly complex.
It is. And they knew that traditional mathematical models, simple feedback loops, weren't enough. You needed something more sophisticated. They called them semiotic models.
Semiotic, like signs and symbols.
Exactly. Models that could capture not just the structure, the formal relationships, the syntax,
Yeah.
but also the meaning of things, the semantics.
Meaning, like what a building is for.
Yeah, or what a city represents, what its purpose is, and crucially, also the user's goals, the pragmatics. What do you want the system, the city to achieve?
Syntax, semantics, pragmatics. Okay, so it's like applying language concepts to control systems.
That's a great analogy. They use simple examples, like a playing card. The picture is syntax. What it means in the game is semantics. How you use it is pragmatics.
Okay, I see.
Or a metro sign. The sign itself is syntax. Where it directs you is semantics. You actually following it to catch your train is pragmatics. Complex systems, they argued, need models that get all three layers.
So a control system for a city needs to understand it's not just roads and buildings, but a place people live, work, interact. It needs that deeper meaning.
That's the idea. They also made this distinction between procedural knowledge and declarative knowledge.
Procedural versus declarative.
Yeah, procedural is like instructions, algorithms, a recipe, or the steps to calculate something. Declarative is facts, relationships, like knowing triangles have angles adding up to 180 degrees.
Got it. Instructions versus facts.
Right, and traditional models were often very procedural. But these semiotic models needed to handle declarative knowledge effectively. Their triangle example was great. Knowing the fact that angle z equals 180 helps you choose the right procedure to calculate the area, depending on what info you have, sides, other angles, whatever.
Okay, the fact guides the method. That makes sense.
And they were developing languages for this. Predicate languages, relational languages, using semantic networks. Think node link diagrams showing cars at intersection.
Okay, yeah.
And frame languages, which were a major road intersection.
Situational control.
Yeah, the insight was that humans manage these incredibly varied situations using, well, natural language descriptions, mental texts, and actually a fairly limited number of decisions cover most cases because we understand the meaning of the situation.
Right. We grasp the overall picture, not just individual data points.
Exactly. So they thought, let's try coding those semantic characteristics, that situational meaning, into the computer control system.
Fascinating. Capturing the qualitative state, not just crunching numbers.
And beyond control systems, another really insightful prediction they made was identifying a whole new branch of the economy. They called it the information handling industry.
An entire industry just for handling information. In 1984, that feels incredibly ahead of its time.
Doesn't it? They saw this sector built on computerized info processing growing way faster than traditional manufacturing.
Wow.
They actually framed it like this. Get this. They predicted for the USSR, it would grow 8 to 12 times by 1990.
8 to 12 times in just 6 years. Based on information processing. That's a huge bet, and it really shows they grasped the potential, even if maybe the global PC revolution played out differently than they might have foreseen from Moscow.
It really underscores how clearly they saw the transformative economic power of IT. But it wasn't just industry and infrastructure. They also looked at cybernetics hitting, well, the arts and culture.
The art, seriously, how does cybernetics fit with art?
Well, they started with the historical links, math and art, like the golden section in design, that kind of thing.
Okay, sure.
But they also saw the computer as an aid for artists, helping with, say, the tedious bits of animation or aspects of sculpting, or even giving composers musical blanks.
Musical blank.
Yeah, like basic harmonic patterns or melodic ideas to start from. but the emphasis was always on assisting the artist, not replacing them.
Right. A tool, not the creator.
Exactly. And they also discussed doing quantitative analysis of theater
Analyzing plays with numbers. How?
by having experts rate performances on lots of attributes: comic, melodramatic, thrilling, modern, whatever, and then using stats like correlation and factor analysis to see how these elements related in specific productions.
So, data analysis applied to subjective art, trying to quantify taste.
Sort of. They could check if intuitions held up quantitatively or find surprising links. They even talked about creating numerical profiles for different genres or mapping theaters onto scales like amusing versus serious or modern versus traditional.
Wow, that's like an early form of computational cultural studies.
It really is. They also touched on using information theory, trying to measure aesthetic substance,
Yeah.
often linking it to unexpectedness in art.
Interesting.
And significantly, they talked about experiments in machine poetry and machine music composition.
Computers writing poems and music.
Yeah. They specifically mentioned Arkady Zarepov's work in music. And the kicker was, in his experiments, listeners often couldn't tell the difference between the human composed and the computer composed pieces.
Really? Even if they thought they could?
Apparently so, which, really challenges your assumptions about creativity and where it comes from, doesn't it?
It absolutely does. If you can't distinguish the output,
Right. And the book argued that successfully simulating these composition mechanisms could actually help us understand human creativity better. They also mentioned using cybernetics for planning in the cultural sphere sociological surveys, measuring a personal culture index.
a personal culture index. What on earth is that? Sounds very planned economy.
It does sound like an attempt to quantitatively track engagement with arts, culture, societal norms, probably to guide cultural policy. But moving beyond arts, they saw potential in the humanities too.
Like what?
Mathematical linguistics came up, especially the problems with machine translation. They recognized how hard it was to formalize human intuition, and that language grammar isn't always neat and tidy like, say, Latin.
Yeah, machine translation was clearly a tough nut to crack, and they saw why the fuzziness of real language.
Exactly. And they had this vision of using cybernetics for a truly objective analysis of human society.
Objective analysis of society.
Yeah, they use this funny analogy. Imagine an alien watching humans, seeing a crowd totally silent at a play, or people making weird gestures with bottles, and trying to figure out the underlying system, like studying an anthill.
Huh. That's a great image. Trying to see the patterns from the outside.
Capture the idea of trying to formalize things like psychology, communication, social groups as basically information problems, where maybe computer simulation could help find the core rules.
Okay, so applying systems thinking everywhere, did it get even more personal? Like relationships?
Amazingly, yes. The book talks about using computers for matchmaking, computer dating services.
Computer dating. In the Soviet Union in the early 80s, that feels unexpected from the usual picture we get of that time.
It does, right. They even included stats on marriage rates, how people usually met, and data from these early computer dating services, number of clients, how many matches led to marriage.
Wow. And what did the data suggest? Were the computer matches successful?
Well, here's the really interesting claim. They said the divorce rate among computer matched couples was negligible.
Negligible. Really?
That's what they claimed, which they argued made it worth serious study. The core idea was psychological compatibility, like screening astronaut crews.
Right.
But the huge challenge, obviously, was how do you quantify personality? How do you measure compatibility numerically?
Yeah, that's the multi-million dollar question. Still is.
They mentioned the debates: do similar people get along better or opposites attract? And studies looking at how people rate each other within groups. It was clearly an active area of thought.
So cybernetics wasn't just for factories, it was potentially for finding your soulmate too.
There may be for optimizing the groups you work with.
Yeah.
That was another big idea. The human collective.
The collective, like a team.
Yeah, or a research institute, a design bureau, viewing it as a kind of super organism or super brain that's
A
evolving.
collective superbrain. That's a striking metaphor.
It is. But they also pointed out the gap between the potential efficiency of these collectives and their actual output. And they talked about emergency, these mysterious bursts of creativity or productivity that sometimes just happen in groups.
Right, when a team suddenly clicks and achieves something amazing more than the sum of its parts.
Exactly that. So they framed the collective as a hierarchical cybernetic system
Yeah,
and asked, how do you organize an optimal collective?
okay.
They compared it explicitly to designing a computer for a specific job, but admitted it's way harder with humans.
I bet.
Yeah.
So, what factors did they think mattered for an optimal team?
Things like matching skills to tasks. They had a great line. No people without talent, only in the wrong jobs.
Nice.
Determining the right size, they warned against making teams too big, citing Norbert Wiener on redundancy. And leadership was critical.
Leadership skill.
Yes, skill and authority. A leader's influence, they argued, works by closing the gap between their program, their vision and plan, and the team members' programs, their understanding and buy in. That's why maybe long term leaders are often more effective. They build that alignment over time.
Interesting. So, leadership is about synchronizing the team's mental models.
That's a good way to put it. They also flagged psychological incompatibility as a major reason people left research jobs. One study they cited put it at 20%.
20%, that's huge. It really highlights the practical impact of those soft factors.
Absolutely. And they mentioned attempts to quantify personality traits within groups, talent, diligence, ethics, motivations to understand these dynamics better, while admitting how complex and sensitive that kind of analysis is.
Yeah, measuring those things objectively sounds incredibly difficult, maybe even intrusive.
Definitely pushing boundaries.
Yeah.
But all this thinking about applications and potential naturally led them into predictions and future visions, some drawing on earlier forecasts.
Okay, let's hear them. What did the future look like from 1984, according to these Soviet cyberneticists?
Well, they revisited some famous predictions, like Arthur C. Clarke's chart from the 60s.
Clark, yeah. What did he predict?
Things like translating machines by 1970,
Ah.
AI by 2000, robots by 2030, machine intelligence surpassing human intelligence by 2080, and a world brain by 2090.
Wow. Looking back now, machine translation definitely happened. AI is here in force, though maybe not quite the 2000 vision. Robots are everywhere in industry, but world brain by 2090 still feels pretty far out, doesn't it?
It does. They also cited another forecast digest from 1970, predicting things like the sheer number of computers, memory capacity, huge encyclopedic data banks by 1980,
Okay.
machines reading handwriting by the late 70s, understanding voice commands by the early 80s.
Some of those seem surprisingly accurate for 1970. Memory, data banks, early pattern recognition. Maybe they underestimated the number of personal computers, though.
Quite possibly. The scale of that shift was hard to grasp early on. But beyond those technical forecasts, they got really speculative.
Oh, like what?
Totally new ways to communicate, including direct mind to mind transfer.
Whoa. Okay, definitely sci fi territory there.
And this concept of cybernetic doubles, CDs, artificial beings that could operate independently in places humans can't go.
Like space explorers,
Yeah.
robots.
Highly autonomous, intelligent ones, yeah. Exploring deep space, colonizing planets, even regulating their own relationships.
Okay, that's a big vision.
But it led to tricky questions, like what lifespan should a CD have? Hundreds of years, thousands, forever.
Hmm.
They contrasted it with biological life, where lifespan is tied to reproduction, continuing the species. A CD's lifespan, they argued, would be tied to its task, its mission, not biology.
That opens up huge philosophical cans of worms about purpose and existence for artificial life.
Doesn't it? And one contributor, the astrophysicist Shklovsky, laid out this sequence for matter evolving, non living, then living the natural intelligence,
Yeah.
possibly leading to artificial intelligence as the highest phase.
Positioning AI as the peak of universal evolution. That's a bold statement.
And he connected straight to SETI, the search for extraterrestrial intelligence.
How so?
His argument was any truly advanced civilization, type 2 or type 3, harnessing star or galaxy energy,
Yeah.
they'd likely be artificial intelligences because of the advantages potential immortality, resilience, things you'd need for interstellar travel, for managing things on galactic timescales.
So if we meet super advanced aliens, they might be machines.
That was his thinking, which then circled back to the Fermi paradox.
Where is everybody?
Exactly. If AI is the likely endpoint and potentially common, why haven't we seen signs of these super civilizations? The book suggested the usual possibilities. Maybe civilizations destroy themselves first, or maybe life and intelligence are just incredibly rare.
It's amazing. This book starts with defining cybernetics and ends up grappling with cosmology and the biggest philosophical questions about our place in the universe.
It really shows the breadth and depth of the questions they were tackling. And looking back now, so many of these debates, these ideas, they just echo so strongly today, don't they?
They really do. I mean, how do those 1984 debates about AI, automation, machine creativity, how do they feel relevant now? We're still having almost the exact same conversations, just with, well, much more powerful tech actually in our hands.
Precisely. The worries about jobs, The questions about genuine creativity or consciousness in AI, the philosophical knot of just defining intelligence, they were right there grappling with it decades ago, just through their specific lens.
And some applications they talked about are here, maybe in different forms. That information handling industry. Spot on, just maybe bigger and more global than they imagined. Automation is everywhere. And while mind to mind transfer is still fiction, we absolutely use computational tools in art, law, social analysis. Even dating apps are basically computational matchmaking, right?
Yeah, although maybe our approach now to using computation for complex human systems like culture or team dynamics is often perhaps a bit more cautious, more aware of unintended consequences and the limits of just formalizing everything, compared to maybe a more top down 1984 perspective.
That's a fair point. It makes you think about these enduring questions. What is intelligence, really? What does it mean to be conscious, creative? And where do humans fit as technology keeps advancing, learning, adapting, maybe even creating?
They're not easy questions, and this deep dive really shows they've been on the minds of smart people for a long, long time, evolving alongside the tech itself.
Well, we've certainly covered a huge amount of ground today exploring this really unique 1984 Soviet perspective on cybernetics and where it was all heading.
We really have. It was this fascinating mix, wasn't it? Some incredibly sharp technical and economic insights, really ambitious, sometimes wild visions for the future,
Yeah.
deep philosophical debates about intelligence, and these surprising explorations into art, culture, even matchmaking.
It's just so clear that experts back then were already wrestling with the same fundamental questions about tech, humanity, and the future that we are still debating right now. For them, it wasn't just about building faster computers, it was really deeply about what these machines meant for us as people, as societies, maybe even for the future of intelligence itself in the cosmos.
Right, they saw the profound changes coming.
So, maybe a final thought for you listening, drawing from this fascinating source. If intelligence can potentially move beyond biology and become a property of highly organized matter, like Shklovsky suggested, what does that imply for the future evolution of life? Or, maybe closer to home, how can understanding the dynamics of that collective genius, the team, as a complex cybernetic system trying to optimize itself, how can that apply to the groups and organizations you're part of today?
Those are some heavy duty questions. So what I'm gonna do is try interaction function. Never tried it before. Let's find out. Let's find out together what it's all, what it implies. Make this a little more clear so you know what's going on. So we hit the play button there for the source. Now we're going to try the interactive, see if it's functional. So there's a waiting period.
Okay, let's unpack this. We're diving into a really today, a book from 1984, Soviet Union, called Cybernetics Today.
Right.
And this isn't just any book, is it? It's a essays and discussion Soviet scientists.
Yeah, physicians, corresponding members of sciences. They're talking cybernetics, automation, AI, past, present, and future as they saw it then.
And that date, 1984, it just sets such a scene.
It really does. I mean, you're right on the edge. Personal computer revolution starting to spread widely in the West, rooted in a very different tech world.
Society, definitely.
Absolute perspective from that moment, from those. It's a very,
Yeah, absolutely. So our mission, I guess, for this deep dive is to pull out the key ideas, the surprising predictions, the debates that were happening almost 40 years ago now, and see what insights this specific offers us today about, well, man, machine knowledge, all of that.
What did they focus on? What maybe slipped by? And what questions were they asking that, well, still feel incredibly.
Exactly. It's like holding up a mirror to books about AI and seeing it reflected through, well, brilliant minds from a different time and place.
Couldn't put it better.
Let's start right at the beginning. Cybernetics, how did they define them in 84?
Well, the book basically presents it as the science of control and information handling. That's the fundamental.
handling. Okay.
Yeah, it covers the mathematical side, the technical side, but also the theory data gets transmitted, how it gets processed.
So it's kind of the study of manage themselves and deal with information.
That's a good way to put it. Whether those systems are like machines or biological organism, social groups.
Then much broader than just building computers.
Oh yeah, much broader. Oh, our listeners got something to share. Let's hear it.
Hi there. I was wondering, what is the status of cybernetics in present day? Is it still in extent at universities worldwide?
That's a great question. It's definitely still around, though maybe not always under the cybernetics label.
Right. As the book actually touches on, there was a trend even back then to use other terms.
Exactly. You see computer science, systems theory, even informatics being used for related fields.
But the core ideas that focus on control and information processing in complex systems, that's
Absolutely. You'll find research groups and university departments focusing on things like robotics, AI, complex systems modeling.
and a lot of that work really foundation cybernetics. It's more integrated now, maybe, into those other disciplines.
Think about feedback loops in machine learning or the study of self. That's pure cybernetics in action.
So while you might not see as many departments explicitly named cybernetics, the field's influence is still very strong in a lot of areas.
Precisely. It's woven into the fabric of many contemporary scientific engineering fields.
Oh, yeah, much broader. It's about the underlying principles. And the book points out that by the mid 80s, cybernetics had already sort of faced some correction.
Correct.
There's connection issues. Ah, phooey. They were just getting good. Well, we'll try this some other time. So yeah. So this has been Military Industrial Museum. I try to stream every day at 9 p.m. Pacific Standard Time, so like California time. And I'll just try to find something to stream. So I thought this would be kind of interesting. Um, it is, but yeah, I got to fix my Starlink dishy antenna. It's losing tracking, and then we get these gaps and these fade outs and stuff. It's not great. So if I want to get serious with this, I got to work on that. And to do that, I better get some good food. I haven't eaten good food in a long time, so my technical and mental facilities are getting kind of sluggish. So, all right. Well, thanks for tuning in. Check out my channel, Military Industrial Museum. Got a lot of AI music, some AI anime, some pretty cool stuff. I want to bid you adieu. I don't know what I'm going to do next here, but I don't want to make this stream too long. All right. Thanks so much. Take care.